Hello viewers, welcome back. This is going to be somewhat of a special episode because firstly it's a good old-fashioned teardown. This is going to be a Quantel free zone, which I'm sure some of you will be happy with. The other reason why this is slightly special is because this bit of kit, which is here, has been purchased by the funds supplied to me by my Patreon supporters. So I would just like to thank all those people here, just in that little box there. They paid for this teardown. If you want to be a supporter as well, then follow the links in the video description and you can bung in as much or as little as you like. So I've still got some funds left over from buying this, so hopefully I'll be able to pick up some other interesting bits in the near future and get those torn down as well. Right, so let's get cracking on the teardown. So what have we got here? This is a Hewlett-Packard branded machine. It's a HP 1046A and it's called a programmable fluorescence detector. Now this is actually used as part of a HPLC system, which is called High Performance Liquid Chromatography or High Pressure Liquid Chromatography. So this takes the high pressure stuff, don't really know much about it, but it runs through this machine and it excites the sample with a frequency of light and then reads back what is fluoresced out of it. So this is kind of like a tunable, shine one frequency of light on something and read what comes back. So in theory it's a fairly simple bit of kit, but these things are often more complicated than they first appear. So I think the way this would actually work in practice is you have a feed in and an out on the side here. I'll show you all around it in just a moment. And that feeds in the sample. It runs through a set of optical and high pressure thingamajigs, and there'll be probably two diffraction gratings, one to control the frequency of the excitation light and another to control the frequency of the fluoresced light. So you can sort of tune in on a specific frequency of light coming out of the sample. So there's probably going to be a couple of motorised diffraction gratings. There will be a photomultiplier and a light source and all the little control electronics to actually make it work. This wouldn't be like a one-time kind of sample. You wouldn't like put a sample in and just do a detection thing. You would run the sample through this over a period of time, and then it would produce a chart of the different levels of the frequency you're actually looking for. So this would be a long-term thing. I don't know how long these take to run, maybe minutes or possibly hours. So I would imagine the data is fed out the back and then goes to a PC or something like that. So as you can see here, we've got a control panel on the front with various buttons to do sort of related stuff. We've got EX and EM, that's excitation frequency, emission frequency. We've got PMT gain, so that's going to be how much gain you apply to the photomultiplier. Lamp, probably the lamp output level. Various other bits and bobs. I'm not really sure how this actually works in actual operation, but I'm not going to go along and read the manual, I'm sorry. So we have a vacuum fluorescent display, it looks like in there. Obviously this is fairly old. I think it dates from probably the late 1980s up into the 1990s, I would have thought, looking at it. It's pretty well made. I think it's a magnesium chassis. It doesn't seem to be aluminium. I think all this is magnesium. Round the side here we have the input and output ports, so the lines would have just been screwed in there. Round on the back we've got a remote control port and another one and a waste port. I'm not sure what has actually been run through this, so I'll probably wear some gloves when I start taking this apart. And we have an analog out, so presumably that would have been run through onto I guess actually if it's analog then there won't be any digital acquisition in here. It's probably just going to be fed out as an analog signal, and then that might have run into an analog chart recorder or something, or into some kind of device that does digitizing of the signal. And then on this side we've just got power switch, fuses and the mains input socket. One thing I did notice on here, it has these little plastic inserts which can be removed, and underneath we actually have a similar arrangement with these odd little feet that sort of screw in here. So I think this is obviously meant to stack on a big pile of equipment, and these feet sort of lock everything together. So it's quite a nice, interesting design feature there. Right, let's get the screwdriver in action. So there's just a couple of screws on the side panel here and some on the back. Let's see how this comes apart. It is interesting that they use these large slotted screws to put the case on. Probably means they expected at least some users to be able to go inside and do something. So yeah, you wouldn't put those on something that's not going to be user adjusted or user maintained or something. So there's obviously going to be something inside. Let's take the lid off. So yeah, it does feel like magnesium this. The colour's not quite right for aluminium, so I would say that is magnesium with a load of blacked out area. Obviously this is an optical device, so they don't want any stray light bouncing around, and we've got a rather icky bit of foam there, so I'm going to put that well out of the way. Right, it is a somewhat simpler than what I expected, but then given that we spotted that analog output on the back, it means there's probably not going to be much in the way of analog to digital sampling going on. So really the stuff that's in here is just for controlling the light, the photomultiplier and the 2 diffraction gratings. So yeah, kind of to be expected, I guess. So we've got an optical block in the middle here. Looks to be a great big machined aluminium block. We've got the power supply at the back, and we've clearly got another power supply down there which is running up to this device here. I'm going to hazard a guess that that is the lamp and the light source, and this over here is the photomultiplier. Yeah, I think I can just see Hamamatsu written on the side there, so not surprising. We've got a ribbon cable running over to the front panel and a couple of cards that plug into a small little motherboard down on the bottom, which just looks like it's for power, it seems. A little bit of data. They've got a connection that runs over to the front panel that comes off there. So we just need to take this apart a little bit more, and we'll see what there is, because I suspect most of the interesting stuff is going to be in here. Now I think these are pretty loose, so I think these just come off just like that. And is that a date code? 3488? 1988, 34th week possibly. Now I don't think this one's really going to come out because it's got those high pressure pipes running in there. They're probably very fine capillary kind of things. Let's have a look at these boards. So, and there we are, 3rd of Jan 1989. And this board is labelled DAC, digital to analog converter, so that might be controlling the photomultiplier out gain or something. Could be doing all sorts of things, I suppose. Made in Federal Republic of Germany. So it's not a huge amount going on there. We've got a Burr Brown, that'll be a DAC I would imagine, and some 7.4 series stuff. And this card is quite clearly a little microprocessor card which runs the front panel. We have an Motorola MC6809, and we've got a ROM there. So yeah, a little microprocessor board. We do have a battery there as well. That'll be a lithium. Ooh, sounds a bit crusty. Sounds a bit crusty and crunchy. Yeah, I don't suppose there's anything left in that. I'll tell you what, let's have a look. What do we reckon? Do you think it was flat, or there's still something in it after all these years? Look at that, 3.7 volts. Don't you just love primary lithium cells? So yeah, I'm not sure what the lithium battery was there really for. Probably just to hold the last user settings, to be honest. There'll be stuff on here to communicate with that remote port. So there might be an RS232 connection there. That's about it. We've got a reset button, and that's pretty much it. Now I just spin this round, you can get a better view of that little motherboard down in the bottom. It's only that sort of size, so not very big at all. As I said, it just looks like power distribution really, and sending the control wires over to the front panel. We've got connections up to the photomultiplier board, power supply connections that go out to those remote ports, some fuses and LEDs. And that's about all she wrote on that. Right, what I think I might do now is just remove these power supplies out, give me a bit more room. So there we have the main power supply, interesting HP branded transformer there, and we have the bulk caps there. Oh! Right, so this is something I see a lot of in some of the stuff that I tear down and take apart, is these old Reefer X2 filter caps. You can always tell them because they're always the same colour, this sort of horrible yellow colour, and quite often you can sort of see little cracks and stuff in the plastic, and it's often swollen. These have a notorious habit of just spontaneously combusting, filling your room and your house with putrid, horrible smoke. So yeah, be aware of those. If they do go, you can just remove them. Generally, if you just want to be a bit bodgy, you could just remove it and just leave it out, but really you should replace them. But yeah, those often go, and it looks like that one is getting close to going nuclear on us, I think. I'm surprised that one hasn't gone already. So yeah, so that's the power supply. Yeah, we've got a mixture of Nippon, Chemicon and Sprague caps on there. Interesting that this is a HP device, but it's made in Germany, so that'll be why you've got the Sprague caps there. It's interesting that a lot of the things in here do seem to be user replaceable. So that power supply was held in with just one Phillips screw and a thumb screw, and this power supply here, it seems to be just held in with a thumb screw, so, and it is pretty tight. Well, actually it might just be the cover. Yep, so it is actually still screwed down, so yeah, a user removable cover. So this will be the high voltage power supply for the lamp. What kind of lamp? Xenon or something like that. I'm not entirely sure. So we've got a load of screening wire around it and some high voltage wires running over there, so we will have a look at that when we start taking the optical parts to pieces. And we've got another of those Reefer X2 caps in there as well, so oh, and that one has actually started to crack, so that one's on the edge. So there is a better shot of those Reefer caps there, and you can just see the crack in the outer plastic there. So yeah, that's ready to go. Bang, bang, fizz and pop. So that is the power supply for the lamp. It's obviously a switching boost converter, give you some high voltage. I'm not sure what this will be running at. Interesting, this one is dated 1992, so quite a bit newer than the other board that we took out, so it's quite possible this has been replaced in the past. Now I think this front panel is actually user removable. There's a couple of tabs here which just sort of roughly hold it in. There's a couple of screws on the front, so I think if I take these out we should be able to remove the front panel. And those are captive screws as well, so yeah. So I don't suppose there is a lot in here, apart from the button panel and the vacuum display. We'll have a look at that after we've had a look at the good bit in there. So we're starting to see a bit of icky goo and stuff around on the bottom there, so there's obviously been some fluids leaking inside, so I think it might be getting close to putting some gloves on. So running into this optical block, we've got one cable just here, it's just labelled J2. We've got the lamp, and we've got another cable at the back, and then a cable running up to this photomultiplier board. So I'm kind of hoping that this block will just come out as a complete unit. There's a screw there, I expect more than that. Yeah, there's a couple around there and another one there. So I'm going to take those out and see if we can get the optical block out, and then we'll start taking the top off. There we are, all rubbered up, well, vinyl anyway. As I said before, I'm not quite sure what has actually been run through this machine, so I'm just being a little bit cautious really. Actually, we've got these here, aren't we? We'll have to disconnect these first. Right, so here I've just focused in on where the pipes actually connect to the actual unit and how they then flow off into the detector. So I don't think it's worth undoing those. I might as well just chop them. But yeah, you can actually see that they are quite thin. Look to be like stainless steel tubes, very, very thin, almost like a capillary. So we should be free to take this out. No, there's still something else. What is it? No, there's a small little, there's always one little connector you forget, isn't there? Right, is that it? No, there's an earth strap. Right, let's have a quick look around this optical assembly. So there's a couple of what would be user accessible panels. We've got one here, there's just a couple of thumb screws on there, so it gives access to something. We've got a foam cover on the back there. We've got another access panel here. Look at that foam that was on the inside of the lid covering this, so it's a bit crusty. And again, we've got the foam thing. Yeah, looks like some kind of filter. Pretty small, but I can't really see what it is. There's no markings on it. I can see. That just slots in a little slot down in there. This looks like one as well. Yep. Oh, it's a bigger aperture. Maybe it's not actually a filter then. Maybe it's just an aperture. And we got one in here as well. Yeah, I think it's just an aperture. I think there's actually a filter. Speaking of which, there's a couple of handwritten notes on here. EX1, EM11, and then a date, and we've got EX6 and EM3, and a date. Those are 1995, 1994, 1995, and we've got this here, something filter installed. So let's see, ozone filter installed December 1992. So that's that bit. Right, let's turn around here to the photomultiplier section. So there'll be a high voltage generator to generate the high voltage for the photomultiplier, which is probably going to be in the region of plus 900 volts, probably something around that sort of territory. But they can run up to sort of 1200. And we've got a load of analog goodness going on. Some analog devices, parts, caps and stuff. So we will try and have a look at that later. There appears to be only 2 wires going into the photomultiplier, so that probably means that oh, actually there's 3. There's 2 there and 1 just there, labelled AN, so that's the anode. So the dynode chain will be built into this base, which is probably why it appears to be potted. So that's pretty simple. So we'll take a look at that when we get a bit further inside. We've got this waste pipe at the bottom here. And we've got another user accessible hatch here. So we've got the in and out here. Ah, yes, it does come out. Oh, I see. So this will be the part that allows the fluid to run through and also gives you an optical path through. So if the lamp is here, that's going to be coming up. So the diffraction grating is probably, diffraction grating for the lamp is probably up here, and that shines down here through the sample and then goes that way, and then there's probably a diffraction grating which goes up. There's probably all sorts of funny paths in there. So that's a lovely stainless steel machined block with some optical bits in there. I'm not quite sure whether you can see them. There's what looks to be a glass window. Don't know whether you can just see it down in there. So I think the next thing to do is to remove this top cover. So we've got a metal cover with foam just to block out any light leakage. Wow, it looks amazing in there. Yeah, so we can start to see how the light paths work now. We've got the light source over here, so that emits the broadband light over to this diffraction grating here, which is mounted on a movable table, which means that it will tilt the diffraction grating, and the different frequencies of light will then pass across this aperture here, which will then go into the sample. excite the sample. The emissions will then be viewed through this window, through this filter here, onto this diffraction grating, and then that is bounced into the photomultiplier. So, as I said, these are mounted on a movable table. There's a micro switch down in the base there with a little arm. So, and underneath there is a stepper motor with a little arm on, which runs through an optical sensor. So this will, during the initialization process, this will run the motors until the micro switch is depressed, meaning it's returned to its 0 position, and then it can just count the number of revolutions from there outwards to calculate the actual frequency that you're actually wanting to look at. So we've got the same process again on this side for the emission. Be able to see this turning away, moving the grating mirror. So it appears that these are just an aperture. It's just a way to give you a clear demarked region that is actually coming through. So slightly larger in that one because that's the emission light. So it'll be coming from the source and coming outwards. So you want a nice, as much as the light as possible going into the photomultiplier, and for the excitation you probably want as small as possible, just so you can focus it down into just where the sample area is. The filter that's installed here, which is just on a little metal spring-loaded thing, is labelled 280 nanometers. Nice, lovely ground glass filter there. Also worth noting down here, there is a small sensor, probably temperature, I would imagine. I can't quite see what it is. It looks like it might be a diode. Yep, we have an old school glass diode there. So these wires are connections for the stepper motors. Little interesting thing here, you can see this side looks absolutely fine, but this side here, inside the chamber, it's all yellowed. So there's probably some UV damage coming from this light affecting the cable there. So it's obviously started to make it degrade. So let's see about removing this lamp, which does seem to be fairly well secured in there, but there is a couple of screws on the outside, so let's just try removing those. I think this is not really coming out how I'd like it, and I don't really want to have it explode on me. So what I'm going to do, I think this heat shrink and this stuff here is getting in the way, so I'm just going to cut that off with a knife. And it doesn't want to come out. Oh no. Okay, obviously that doesn't come out like that. Right, there's a couple of Allen grub screws just here, so maybe I can release this outer ring. There we go. Yeah, I think this is actually just plugged into a socket, so just going to gently yeah, it is coming slowly. There we go. So the bit on the back here is a trigger module. So yeah, this is going to give that a bit of a high voltage kick just to fire it off. Yeah, kind of quite a nice little self-contained module, that, to be honest. And we have this lamp here, which is labelled E, G and G. You can see two electrodes in there and a little arm pointing out to one of them, so maybe that's the one that actually gets fired by that igniter module. Got a number on the side, a bit worn off. Is that FX267? That looks like it's a getter. You can see two little circles in the background there. So those would have been, so those would have been fired after it was assembled, and you would expect to see a nice gold, sort of bronzy coloured area on the back there, but these have gone white, so I suspect this has gone gassy and it's possibly not working anyway. Right, let's take a look at the photomultiplier. Now, I suspect if I just remove this board, the whole thing should slide out. So the photomultiplier is a Hamamatsu R212HA, side windowed photomultiplier, and this should just unplug from here. There we go. So not a lot to see on that, I'm afraid, because it's all been covered in this black metal covering. And then we have the controller board. So yeah, we've got more Sprague caps. Those look like Nippon Chemicon. Decent quality stuff. Some analog devices, an AD1813, and down here we've got an AD1826. And then underneath there we're going to have the high voltage multiplier. It won't be particularly sophisticated unit under there, probably very similar to the one that we saw in the lamp power supply, just a bit smaller because the photomultipliers require so little current. It's you just need high voltage really. So I'll probably save the base off that. They're quite nice to have the complete base there with all the diode resistors in. That would be quite nice to save, maybe of use to somebody. So it might be worth having a look at this little windowed flow chamber thing. I think, well, quite clearly we've got input and output, so they come in separately. One of them runs directly into the, whatever you call it, the little glass, probably it might even be quartz windowed tube probably, and then comes out and then goes through this. Not sure what that is. And then back, I didn't really make a note of what was in and what was out. Let's just take this screw off and see what this is. And it is just a thing. I wonder whether that is like a restrictor, where there's a coil running, the capillary runs around in a coil and creates a flow restriction, possibly. We've got a tiny termination piece on the end there, and I don't know whether you can see there. There's probably a very, very small hole in the end there. Yeah, similar thing on there. So this thumb wheel looks like maybe it tightens down the actual chamber. Yeah, we do have what appears to be a small, probably a quartz glass window which the sample runs through. And then in here it looks like we have two lenses in there as well. There's a glass lens just in there and in there as well. So just to focus the excitation light and the emission light out to their respected, out to those diffraction gratings. Yeah, quite a fascinating little thing. There's the actual quartz window. And finally, the last thing to look at is the keyboard and display panel. An aluminium back there, and a large circuit board which is going to have all the clicky buttons, and it's all bolted in. Okay. Right, so there's quite a bit on here really. We have the vacuum fluorescent display, which is a single line. Quite a nice big display module there. Some nice clicky switches on there. We've got a couple of ICs over here. That's probably off, using these as like a buffer to buffer the signal down the cable. We've got a number of Rockwell devices on here, probably to run the actual screen. Really, really quite nice switches, those. Might be tempted to desolder some of them. Well, I think that pretty much concludes the teardown of this fluorescence detector. It's really quite an interesting bit of kit, and yeah, there was more in here than I expected, to be honest, so well happy with that one, and I hope you found it interesting as well. If you want to learn a bit more about high performance liquid chromatography, then I will provide some links in the video description, probably off to Wikipedia. Thanks for watching everybody, and I'll see you on the next video. Bye for now.